Monitoring IT devices is incredibly important because it's in our interests to be proactive rather than reactive. For instance, it's better to know when a hard drive has reached 70% capacity than it is to find a computer has stopped working because it ran out of disk space. Now, there are lots of monitoring tools out there that you can use, but an interesting open source combination that's available for free is Prometheus and Grafana. But how do you install Prometheus and Grafana in Docker? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Now, as this video is specifically about installing Prometheus and Grafana, I'm going to assume that you already have Docker set up. If not, I do have another video available which shows you how to actually install Docker in a virtual machine on Proxmox VE so that you can take advantage of both virtualization technologies. Now, in order for Prometheus to gather metrics from an actual device, it needs access to an exporter. So this is going to make information on the computer available in a presentable format. And then on a regular basis, Prometheus is going to check up on that exporter and gather the metrics at that moment in time. Now, what we're going to do for this video is to actually monitor the actual computer itself that Docker and ultimately Prometheus and Grafana are running on. And because it's a Linux computer, we're going to use the node exporter for that. So what I'm going to be doing is to use Docker Compose for this. So I need to edit the docker-compose.yml file. As you can see, I haven't set anything up yet, so it's completely blank. In which case, I'm just going to copy and paste in a configuration which I got directly from the main website. So what we're doing here is to define our version at the top. We've then got our services section, and then under there you start to define your actual containers. So in this case, we're only defining the actual node exporter container that we're going to be setting up first. Now, for the image, we need to point it to the node exporter image, and we want the latest version of that. We've then got our container name. In this case, we're just calling it node exporter to make it easier to identify. We've then got a command which sets path.rootfs to /host. The network mode is set to host because we want access to the actual network of the host. Process ID of host, and then we've got restart set to unless-stopped. Now, the idea is that we want to be monitoring something like this 24/7. If there's ever a reboot of the computer, for instance, we want this container back up and running. So if you want something running 24/7, you could set the restart as always, in which case it'll always actually start this actual container up. The only problem is you might actually want to carry out some maintenance, in which case I've got this set to unless stopped. So the idea is if the actual container is manually shut down, then don't actually start it back up. On the other hand, if the computer actually reboots, for example, then yeah, restart it back up again. And then finally, what we've got defined underneath volumes is a map for this /host option here. So we're pointing this to the actual / folder, in other words, the root folder of the actual computer itself. And then we've got /host, which is that /host reference within the actual container. And because we're actually just using this for monitoring, we've got this all set to read-only access. We've got RO and our slave as the options for the actual volume. So we'll save that file. Then what we're going to do is we're going to start it up. And I'm just going to use Docker Compose up, which basically is just going to start up any containers that are defined within that YAML file. If they're not already running, that is. We want this running in the background though. In other words, I don't want to leave the actual terminal open because, well, if the computer ever gets restarted, someone will then need to log back in again, for instance. So I want this all running in the background. So that's what the -D option's for. So off it goes. Now, because that image doesn't already exist on the computer, it's actually pulling it down from the internet, and then it's actually running the container. So if we do docker ps, you can see we've now got an image which has just been up for a few seconds. But what I can do is actually check on how that actual export is doing by pointing to the IP address of the computer and then port 9100. We didn't define that within the actual container settings, but that is the actual default port there. So I hit return, and it comes back and says, well, this is the node exporter. All we've got here is our metrics URL. So if I click on that, it actually gives me all of the metrics that it can actually tap into. So this is basically what Prometheus itself is going to connect to and then start gathering this information over a period of time. Now, in order for Prometheus to work, it needs a configuration file. And my goal here is to actually run Prometheus as a container on this computer. And I like to keep things separated. So for that reason, the first thing I need to do is to actually create a folder for it. And I'm going to call that Prometheus. And then we're going to create the actual configuration file itself, which will be called prometheus.yml. And then I'll copy and paste the configuration into that. So right at the top, we've got our default or global settings. And all we're defining here is what's known as the scrape interval. So that's the frequency that Prometheus goes out and actually gathers metrics from things like the exporters. Now, this is a default or global setting. You can change it for individual actual targets as we've defined lower down. So it's quite flexible in that respect, but by default, it's going to be every 1 minute, which seems quite reasonable. I mean, the idea is you don't want to overload a computer too much by checking on it on a very, very frequent basis. On the other hand, you don't want to leave it too long. But what you set this to is entirely up to you. And then below we've got what is defined as the scrape config. So these are basically the tasks or targets that we want Prometheus to check upon and actually scrape. So we've got one which is defined as Prometheus. In other words, we're actually getting it to connect to itself. So for that reason, we're using localhost as the actual target destination, and the port is 9090. Now, these are actually running as two separate containers. So we've got one container, or at least we will shortly, that runs Prometheus, and then we've got another container which is running our node exporter. So for that reason, Prometheus needs something other than localhost to connect to when it wants to talk to the node exporter. I want to keep things as simple as possible. So for that reason, I'm actually going to point it to the IP address of the actual main computer and then port 9100. So this is just exactly what we used when we were connecting and testing Node Exporter within that web browser. But you can use an FQDN and you can go so far as actually setting it up with IP addressing within Docker itself if you want to. But as I say, I want to just keep things as simple as possible. So all we're defining here is just a global default setting for how often we want to pull. And then at this stage, we just want to get it to check up on Prometheus itself plus the node exporter. So we'll save that config, and then we can start thinking about setting up Prometheus itself. Now, because I'm using Docker Compose to set up my actual Docker containers, in order to set up Prometheus, I'm going to have to edit the Docker Compose file. So I'm going to use nano to edit docker-compose.yml. And then in here, we're going to set up the details for Prometheus. So I'm just going to copy and paste in some details. Most of this comes from the actual main website. I've just converted it over for use with Docker Compose. So I'll just paste in the actual container details there, but right up here at the top, we're defining a volume called Prometheus-data. The reason being is that, well, if we don't have an actual volume to store data physically on the computer, the actual data would get lost. We need that information to survive a reboot, for instance. So we get Docker to actually create this volume, which we're calling Prometheus-data. The actual file name ends up as something completely different, but it's a reference that we can use lower down. And then we actually define the container, and we're calling this one for Prometheus here. The image that we're going to be using is this, and then we've got our setting of latest, because we always want the latest version. We're defining the actual container name to be Prometheus to make it easy to recognize what this actual container is. And then we've got the default ports of 9090. As before, I want this to actually restart all of the time unless it's actually been manually shut down, because there might be maintenance issues, for example, and I don't want it to automatically restart under those circumstances. I've actually got to map the configuration file it uses. So it sees a config file as being /etc/prometheus/prometheus.yml. I've got to reference that file back to the config file we created earlier. In this case, we're pointing it to the Prometheus folder that we've got, and then the prometheus.yml file within there. then what we're doing is we're actually mapping this /Prometheus folder that the container sees to the actual volume that we've created up here. Now, this is where things get a bit interesting, because I wanted to use this -web.enable -lifecycle command. So I've got a command section defined. The reason for that is that if you make a change to the configuration file, then you'd have to actually restart the actual container. But there is an option to actually get it to essentially reload the actual config file on the fly. But you have to put this command in to be able to do that. The only catch was when I added this command in, the actual container broke. Without putting that in, things were working fine. But as soon as I put that command in, it kept complaining that it couldn't find the actual config file. So I had to add in an extra command here to actually tell it that the config file is at /etsy/prometheus/prometheus.yml. So just something I ran into specifically because I put that extra command in. But either way, we're going to save these changes now. And then what we're going to do is to actually spin that actual container up. So we're going to use docker compose up -d, so we'll get this to run in the background. It hasn't done this before, so it's obviously going off to the internet, pulling things down. And then once it's actually pulled all of these actual parts down and then created that, it's then going to actually run the actual image as a container. And then it should return us back to the actual shell, because I was using the -d option to run it in the background. So if we use docker ps, it's actually saying it's been up and running for several seconds, so that looks good. So what we're then going to do is we're going to go over to our web browser. We're then going to point it over to the actual Prometheus container that we've got there. So we want to point it to same IP addresses that we're using for Node Exporter, because it's the IP address of the host, but we want to use port 9090, which is what it's listening on. Then if we go to status, for example, and ask for targets, you can see we've got two targets. One's it's referencing the endpoints. This is our Prometheus target. The other one is the Node Exporter. At the moment, we're waiting for the actual information to be gathered. It doesn't have any information at the moment, so we've got to give it a bit of time to actually get that information. But you can also go to service discovery, for instance, to get a bit of a breakdown of the information of those targets if you want. But there we go. It just took a while because it's set to a default interval of 1 minute, which means you've literally got to wait 1 minute. It doesn't automatically start that connection. It waits 1 minute before it then goes and checks the Node Exporter. But as you can see, it's connected, and as far as it's concerned, it's actually up, which is good. You already know the metrics are there, but all we're doing here as far as Prometheus is concerned is just gathering that information here. Now, if you ever do make changes to the configuration, go back to the terminal session, rather than restarting the container, what you can actually do is use curl to tell it to actually restart, or at least reload the configuration for Prometheus. So I'm using the -x option because I want to use the post command. I want to send it this reload command to tell it to reload. So if I send it that, because if I was to just browse to that URL, it wouldn't work. It would be using the get option. So that's the reason I'm using curl. I want it to actually send it a post option. I want to send information to the actual web service. Specifically, I want to tell it to do a reload. And then what I can do is, if I want to actually check on that, I'll go back to the web browser. What I can actually do is point to Prometheus, except the /status URL there, and it actually tells you if your configuration reload was successful. It also tells you when the last reload was. So that's a good way to actually check if the configuration has reloaded. But it is very, very useful because, as I say, it just saves you having to actually do a complete reload of the container. But either way, as far as we can see, Prometheus is now up and running, and it is starting to pull information from the actual Node Exporter that we wanted to collect. Now, it's all well and good having Prometheus gather all these metrics, but we want to see these in a more presentable format. we want them on a dashboard, we want to see gauges, we want to see charts and so on. And that's where Grafana comes in. So because we're going to be setting this up as another container in Docker, we're going to edit the actual YAML file for Docker Compose. And then we're going to put in the details for Grafana. So similar to Prometheus, I need to create a volume for Grafana to use to actually store all of its information in, because we'll be actually making configuration changes and so on. And then what we want to do is to actually create the container here. So let's say right at the top we've got our volume, we're calling that Grafana-data, and that'll get created the first time this spins up. But then we're defining what our Grafana container is, so we're pointing it to the image and we're saying we want the latest version. We're giving it a name of Grafana, so it's a bit easier to identify. I'm going with the default ports here of 3000, and as before it's a case of I want this thing running 24/7, but I don't want it to automatically spin up if I'm doing maintenance. So rather than having restart set to always, it's set to unless stopped. And then what we've got to do is to actually map in the volume. So from the container's perspective, it's /var/lib/grafana, but we're actually linking that over to the Grafana-data volume that we created before. So we'll say that configuration file. Then what we're going to do is to actually spin this container up. So I want to use Docker Compose up -d, so this will all get done in the background. And then off it goes, and it starts to actually download things, and then eventually it'll actually start up the container. Well, the download has now completed, and the container is up and running, but I left it a while because it seemed that the actual web interface wasn't responding, or at least not for a while, so it obviously took a bit of a while to catch up. But now if I open up a new tab, paste in the URL for Grafana and then just hit return, it's now getting to that point where it's asking for me to log in. Now the default credentials are admin for the user account and admin for the password. So I'll click on login. First time you log in, it actually asks you to change that default password, so I'll put in a new one. As ever, I would suggest using something a lot more complicated and longer than I'm using. There is the option to skip if you want, but it always makes sense. You really don't want to be using default credentials. So I'll click on submit. And now it's loading up, and there you go. We've now got Grafana up and running. Well, now that we've got Grafana installed, we actually have to configure it and point it over to Prometheus. So over here we've got an option called data sources, and it's saying here add your first data source. So we're going to click on that, and interestingly enough, the first option right at the top of the list is Prometheus, so we'll click on that. Now you can change the name if you like, but what we definitely need to do is to actually point it to our instance of Prometheus, so I need to copy and paste in the URL for that. So in my case, I'm just using IP addresses, but I've got to use HTTP because we're not using any certificates at all, but it's still port 9090 by default. Then scroll down and click on Save and Test. And as you can see, it's actually successfully connected to our actual Prometheus server, in which case, if we go back to home, we've got an option here to actually create dashboards, because that's what we really need. I mean, we've actually pointed it over to the actual data, but we need a dashboard to actually display all this. Now, if you're just getting started with Grafana, well, that can be a bit complicated if you don't know what you're doing to begin with. But fortunately, there are people out there actually making dashboards that you can use. So if we go over to the website for Grafana, on this dashboards URL here, there's quite a lot of actual dashboards people make available, one of which is this Node Exporter Full, which is specifically for showing the actual metrics that are used with Node Exporter. So if we click on that, you can see you'll get examples of what the actual output looks like. But what we really want is that ID down there, because if I click on copy ID to clipboard, then go back to Grafana, go to the menu and select dashboards. Then on this new drop down menu, if I select import, I can actually paste in that actual ID and then click load. I can change the name if I wanted to, and what I do have to do though is actually point it to the actual Prometheus data source. then if I click on import, it actually sets up the actual dashboard for me. So this is a dashboard that's already been put together that we can take advantage of to make our lives easier. You can then alter things and have a look at this information and find out how it's put together, and then start making your own dashboards. You might be prefer to see things at, but there's a lot of useful information in here. I mean, obviously Prometheus itself has to gather quite a lot of information over a longer period of time. I mean, by default, you're looking at about like 15 days it'll collect, and then it'll start to discard information. But straight away, you can see we're getting some useful information about system loads, RAM utilization, and so on. But you can start drilling down into all sorts of information here that it's gathering as a Linux computer. I mean, network traffic, all sorts of stuff on here about the net packets, errors, and so on. We've got storage, disk space information, read writes, all this. There's an absolute ton of information that's being gathered here. But as you can see, hopefully it is pretty easy to set up, especially when you've got people actually creating these dashboards for you. Hopefully, as you can see, it's not too difficult to set up Prometheus and Grafana once you know how. Granted, we've only got Prometheus monitoring itself at this stage, so you'll want to add other devices. For other Linux computers, for instance, you can install Node Exporter on them, but you'd probably do that as a binary rather than a Docker container. And there are a lot of other exporters available, and usually someone has created a useful dashboard to go with it. Now, although I haven't touched on alerts, Prometheus does support these, so it can alert you when thresholds have been reached, for instance. So I'd say this monitoring solution offers a lot of scope. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.